Hey, 8th grade, this is Miss Harkness, and this video is to go along with Eureka Module 5, Lesson 7, where we are comparing the rate of functions. So here, this is actually the exit ticket for this lesson, and let's get some context in the problem. So it says, brothers Paul and Pete walk 2 miles to school from home. Paul can walk to school in 24 minutes. Pete has slept in again and needs to run to school. Paul walks at a constant rate, and Pete runs at a constant rate. The graph of the function that represents Pete's run is shown below. So this over here, this graph is Pete. Which brother is moving at a greater rate? Explain how you know. Let's start with Paul. Paul's walking. And if you remember, rate is distance over time. So Paul's going to go 2 miles. And I know that because it's right here in the question. He's going to go 2 miles in 24 minutes. Well, if we reduce that, Paul's rate is 1/12. So Paul's rate is 1/12. Then let's look at Pete. So for Pete, we can see here on the graph, there's really one specific ordered pair right there. Just marked it. Forward 1, up 8. So for Pete, his distance is 8 miles, but we don't want to put it over 1. Here's why. The graph says time in hours. Well, if we list Paul in minutes, we need to list Pete in minutes in order to accurately compare their rates. So how many minutes are in an hour? 60, yep. So we're going to reduce this. P equals 2 over 15. 8 divided by 4 is 2. 60 divided by 4 is 15. So now these are the two rates we are looking at. Which is a greater rate, 1/12 or 2/15. So I'm going to just set up the proportion to compare, in case you weren't sure. So how you do it is you cross multiply. 2 times 12 is 24. 1 times 15 is 15. 24 is greater, so therefore 2/15 is greater. Pete is moving at a greater rate. Now, let's think back to the question for a second. It says Paul can walk to school. Pete has slept in and is going to run to school. When you read that, my hope is that you will infer that since Pete is running, he is moving faster. Okay, but now we have just justified that through our work to show that Paul's rate is 1/12. Pete's rate is 2/15. If you're not comfortable with comparing the rates like this, with the proportions and multiplying like that, you could also convert both rates to a decimal and see whose rate is greater. Okay, let's look at the second part. Second part says, if Pete leaves 5 minutes after Paul, will he catch up to Paul before they get to school? So this is a harder question. I'd be lying if I told you it was easy. Let's reconsider their equations. So Paul, he's the one who's walking. His equation is y equals 1/12x. His is the easy one, right? We just brought our rate down, put it in the rate spot, and then x is our variable. Pete, however, when we consider his equation, y equals 2/15, but it's not just x, it's x minus 5, because whatever Paul's time is, you got to remind yourself that Pete is 5 minutes behind that. So if we consider for Paul's equation, if Paul is 2 minutes into his walk, Pete hasn't woken up yet. When Paul's 3 minutes into his walk, Pete hasn't woken up yet. But when Paul's like 6, 7 minutes into his walk to school, Pete is 5 minutes behind that. So let's rearrange Pete's equation to get rid of this parentheses we've got going on. So we're going to use the distributive property. Distribute the 2/15 to the x and the 2/15 to the -5. So that will give me y equals 2/15 x, right? Nothing happens there. Minus 2 times 5 is 10. And then the 15 just stays. Well, you could see hopefully that reduces. So y equals 2/15 x minus 2/3. That's the equation we're actually going to be working with. So now we have a system of equations to solve. Keep in mind, our x, our distance, needs to be less than 2 miles, because if it's going to take Pete 3 or 4 miles to catch up to Paul, well then they would have already arrived at school, because school is only 2 miles away. I'm going to bring down my equation for Paul first. 1/12 x equals, right, we set them equal to each other since they're both in slope-intercept form, 2/15 x minus 2/3. And we're going to find the ordered pair that's true for both of these. All right, I kicked over to a new screen because I need more room. Now, the first thing I want to do is get rid of all these fractions, because solving an equation with this many fractions is going to be a nightmare. So I'm going to create an equivalent equation to get rid of the fractions. So I look at the denominators 12, 15, and 3, and I want something that is divisible by all 3 of those numbers. So immediately my brain says 60. 12 times 5 is 60, 15 times 4 is 60, and 3 times 20 would be 60. So let's create this equivalent equation. 60 times 1 is 60 divided by 12. This gives me 5x. All right, let's bring the 60 over to the 2/15. 60 times 2 is 120. 120 divided by 15 gives me 8x. And then over to my final term, 60 times 2, technically it's a -2. 60 times 2 is 120, divided by 3 gives me 40, so minus 40. Now, I don't know about you, but that purple equation, which is equivalent to the black one, looks way easier to solve. So let's work with it. First thing I need to do, get x all by itself. That's the ultimate goal. So I'm going to move x over, which is going to give me minus 3x equals minus 40. When I divide everything by -3, now, as I solve this out, it looks like x equals somewhere around 13 minutes. All right, now you remember, it only takes Paul 24 minutes to get to school, and it takes Pete 16 minutes to get to school, and they're going to cross each other 13 minutes into their commute, 13 minutes technically into Pete's commute. So yes, they will cross paths. So let's write that. Yes, they will cross paths. Let's review what we did here. First, we compared the rates. We created an equation for Paul, and then we used the graph to find Pete's rate, and we compared them. We determined who was moving faster, which was Pete because he's running. Then we wrote Pete's equation, which was probably the hardest because we had to consider that y-intercept, that he's at -5. He's already 5 minutes behind his brother Paul. And then, lastly, we solved the system. We set the two equations equal to each other, found an equivalent equation, so we didn't have to work with all those fractions, and then solved for x, which I found x, meaning time, right? Because x is usually your time, y is usually your distance in problems like this. X at 13 minutes, their distances will be the same away from home, right? They're going to cross each other, so therefore they will meet up before they get to school. And that's all. Hope this lesson helps.